So this is 8.5 part 2, and I stopped off doing one of these problems, and the problem that I'm on currently is find the exact value of each of the following under the given conditions. And it's asking us basically just to use the sum and difference formulas. So we're given tangent alpha is equal to negative 4/3, where alpha is a value between pi over 2 and pi. So we're in quadrant 2. So just to let you know, in quadrant 2, sine is going to be positive, cosine and tangent are going to be negative. And then it further goes on to say that cosine beta is equal to 3/4, and beta is a value between 0 and pi over 2, so that's quadrant 1. So everybody is positive in quadrant 1. Okay, so let's go ahead and look at part A. A asks us to find sine alpha plus beta. If we look at the sum formula, we're going to see that we're going to need cosine as well. So the first thing I'm going to do is, before I start any of these, is go ahead and draw out two triangles, one of which is going to be alpha and the other one is going to be beta. Now tangent, remember, is opposite over adjacent, so the opposite side to alpha is going to be 4 and the adjacent side is going to be 3. If you use Pythagorean theorem, you will find that the hypotenuse is 5. By the way, I knew this right away because it's the famous triangle 3, 4, 5. So then we're going to also need to do beta. And beta is given as cosine. Cosine is adjacent over hypotenuse, so the adjacent side has to be 3 and the hypotenuse has to be 4. This is not a 3, 4, 5 triangle, because a 3, 4, 5 triangle, the 5 has to be the hypotenuse, so we have to use Pythagorean theorem to find the missing side. So I'm going to take 3 squared plus x squared, and that's going to equal 4 squared. So 9 plus x squared equals 16. X squared equals 7. So x equals radical 7. Okay, and I'm just checking really quick to make sure that's right. Good to go. I'm going to erase this work just to let the triangles be clean. Okay, so let's go ahead and do part A. Sine alpha plus beta. So once again, we need the addition formula. So this becomes sine alpha cosine beta plus cosine alpha sine beta. And once again, I'm going to double check this just to make sure that I did that right. And if I go back up to the top, I get sine alpha cosine beta plus cosine alpha sine beta. Okay, so I'm ready to go, and now I gotta go ahead and plug things in. So remember, in quadrant 2, and this is alpha, alpha's in quadrant 2, sine is positive. So sine is opposite over hypotenuse, so that's 4 over 5. And beta's in quadrant 1, so everything's positive there, and cosine is adjacent, which is 3 over the hypotenuse, which is 4, plus. Cosine is going to be negative because I'm in quad 2, and I have adjacent over hypotenuse, which is 3 over 5. And then sine beta is going to be positive because I'm in quadrant 1 with beta, and that's opposite over hypotenuse, so that's radical 7 over 4. My next step is to find anything common. So I have a 3 in both. 3 is going to be a factor, and then 5 times 4. So if I pull out the commonality, I get 3 over 20, and what's left is 4 minus radical 7. So that's simplified down. Let's look at B. B says cosine alpha plus beta. So I need the cosine alpha plus beta formula. And if I go up to the top, I see cosine alpha plus beta is cosine alpha cosine beta minus sine alpha sine beta. Okay, so let's plug everything in. In quadrant, or alpha's in quadrant 2, so cosine is negative. Cosine's adjacent over hypotenuse, so 3 over 5. And then cosine beta is going to be positive because it's in quadrant 1. Adjacent over hypotenuse gives me 3 over 4. Minus, sine is positive in quadrant 2. So sine is opposite over hypotenuse, so that's 4 over 5. Times beta, beta is in quadrant 1. So I get opposite over hypotenuse again. So opposite is radical 7 over the hypotenuse, which is 4. So I'm looking for commonality, so take out a GCF. I see 5 times 4 in the denominator of both, but in the numerator I don't have anything common. So I'm going to take out 1 over 20, and then I'm going to multiply negative 3 times 3 together to get negative 9. And then negative 4 times radical 7 is negative 4 radical 7. So this is simplified down. All right, so let's look at C. C asks us to find sine alpha minus beta. So I have to look at the difference formula for sine. So if we go to the difference formula up here, we have sine alpha cosine beta minus cosine alpha sine beta. Okay. All right, so I'm plugging stuff in. Sine is positive in quadrant 2. Sine is opposite over hypotenuse, so I get 4/5. Cosine is positive in quadrant 1, so I have adjacent over hypotenuse, so that's 3 over 4. Minus cosine in quadrant 2 is negative, so I have adjacent over hypotenuse, so that's 3 over 5. And then sine is opposite over hypotenuse, and it's positive because I'm in quadrant 1, so that's radical 7 over 4. So once again, I'm looking for the GCF. So I see I have 5 times 4 in the denominator, and I also have a 3 in both. So let's go ahead and take out the GCF, which is going to be 3 over 20. And now I have a 4 left in the first term, and then a negative times negative gives me a positive, and I have radical 7 left in the second term. Okay, so now I have part D left, which is tangent alpha minus beta. Now I know this one's going to be a quotient. So if I look at the formula for this, I have, and I got to check really quick, minus. Okay, so we have the difference formula. So it's going to be tangent alpha minus tangent beta over 1 plus tan alpha tan beta. Okay, all right, I think this is good. I'm just triple checking here. Yeah, it's good to go. Okay, all right, so plug and play. Tangent alpha, tangent's negative in quadrant 1, so let me put the negative sign there, and tangent is opposite over adjacent, so that becomes 4 over 3, minus tangent beta. Beta's in quadrant 1, tangent's positive, so opposite over adjacent is radical 7 over 3. In the denominator, we have 1 plus, and then tangent alpha again, remember, is going to be a negative 4/3 times tangent beta, which is radical 7 over 3. Okay, we have a common denominator and a numerator, so I can write this up as negative 4 minus radical 7 over 3, and that's all over 1 minus 4 radical 7 over 9. In the denominator, I'm going to have to find a common denominator, which is going to be 9, so 1 becomes 9 over 9 minus 4 radical 7 over 9. And then the denominator, I'm going to leave this alone just for the time being. And now I'm going to simplify this a little bit more. Negative 4 minus radical 7 over 3 all over 9 minus 4 radical 7 over 9. Okay, because this is complex, I'm going to go ahead and turn this into a multiplication problem. by taking the reciprocal of the denominator. And now I'm going to simplify this by taking 3 into 9, which goes 3 times. Okay, so I have 3 times negative 4 minus radical 7. So when you distribute that 3, you get negative 12 minus 3 radical 7. And that's going to be all over 9 minus 4 radical 7. And that's going to be your answer. Okay, so we did A, B, C, and D of that problem. It's pretty long. This next one is actually way easier because we have to work backwards. So we notice we have sine of 65 degrees times cosine of 25 degrees, and then cosine of 65 degrees times sine of 25 degrees. And we notice that we only have a 65 and a 25, so there's only 2 angles. So that's giving me an idea that I'm probably using the sum formula. So I can say that alpha equals 65 degrees, and I can say that beta equals 25 degrees. So if I do that, I can substitute in for 65 alpha and for 25 beta. So this looks like this: sine alpha cosine beta plus cosine alpha sine beta. So if I look at the formulas, I will see that that equals sine of alpha plus beta. So if I plug in the values again, remember alpha is 65 degrees and beta is 25 degrees, and I add those together, I get sine of 90 degrees, which we know. Sine at 90 degrees is going to be 1. So like I said, these are a little bit easier, but you have to realize that that's the addition formula for sine in this case. Now this one says to establish identity, no problems, we can do this. The left-hand side looks more complicated, so I'm going to do that. And we know that sine of alpha plus beta is equal to sine alpha cosine beta plus cosine alpha sine beta. So being that said, I can rewrite this by saying that alpha equals 3 pi over 2 and beta equals theta. So the left-hand side looks like this: sine of 3 pi over 2 times cosine of theta plus cosine of 3 pi over 2 times sine theta. And once again, I'm just working on that left-hand side. So now I'm going to simplify it. Sine at 270 degrees, or 3 pi over 2, is negative 1. So I get negative 1 times cosine theta plus cosine at 3 pi over 2, or 270 degrees, is 0. So I get 0 times sine theta, which is going to be 0. So I'm left with negative 1 plus cosine theta, which is just negative cosine theta. Now my left-hand side looks like my right-hand side, so I have established the identity. Okay, this next one, if I look at this, I see that the left-hand side looks more complicated than the right-hand side. So I'm going to start with the left-hand side. So when I do that, I'm going to look at it, and I see I have cosine alpha minus beta. So I need the cosine formula to be able to handle this problem. So if I go up and look at the top, I'm looking for cosine alpha minus beta, and we get cosine alpha cosine beta plus sine alpha sine beta. And what I'm going to do is I'm going to plug that in. So in the numerator, instead of writing cosine alpha minus beta, I'm going to write in cosine alpha cosine beta plus sine alpha sine beta. And that's going to be all over cosine alpha cosine beta. Since I'm dividing by a monomial, monomial means one term, I can break up the numerator into 2 pieces. So this becomes cosine alpha cosine beta over cosine alpha cosine beta plus sine alpha sine beta over cosine alpha cosine beta. Now if I look at this first term, I see that I have the same thing in the numerator and the denominator, so that's going to break down to be 1. In the other term, I have sine alpha over cosine alpha and sine beta over cosine beta. Well, I know that tangent theta is equal to sine theta over cosine theta. So if I use that bit of knowledge, I can then kind of clump together sine alpha over cosine alpha and sine beta over cosine theta. And if I do that, I'm going to see that sine alpha over cosine alpha equals tangent alpha. And then sine beta over cosine theta is going to, sine beta over cosine beta is going to be tangent beta. Now I have the right-hand side, and I've established my identity. Okay, just a word before I just end this video here. Make sure that when you establish identity, you only work on one side, not both. Just one side, and you're trying to make that one side look like the other side. So what you're trying to do is look at the more complicated side, see if you can't use substitution in some manner to make it look like the right-hand side. Okay, that's it for this video. Happy video watching. Go watch 8.6 now.